All right, hey YouTube. In the last video, we saw how to do an SQL injection as well as a cross-site scripting attack. Now we're going to see how to block that using AWS WAF version 2. So let's take a look. And for this, we're going to use the application load balancer. So with the application load balancer, we have the same page as we did on a regular EC2 instance. So let's go ahead and test it out with a cross-site scripting attack. So there we go. We see it's vulnerable to cross-site scripting, and it's going to be vulnerable to SQLi as well. So let's go ahead and enable the AWS WAF. I'm using Terraform for this. So I'm going to rename the file to enable it. We'll do Terraform apply auto approve. Terraform apply auto approve. And this will take a minute to run. So let's check out the console. So currently we have our EC2 instance in the auto scaling group, which is this one right here. And if we go to AWS WAF and look at ACLs, there's nothing in here yet, but it will come up shortly. If we try to create a test web ACL just to look at the options, you could do it like so, and then add in some rules. There are a lot more rules in version 2 than there were in version 1. Also new is this capacity setting, so you're not able to enable all the rules because that would put too much strain on their load balancer, so it gives you up to 1,500 capacity units for your rules. So the ones I like to enable are, oh, and I got throttled. Okay, there it goes. So the core rule set, and then the SQL database. So core rule set does a lot of the OWASP rules. So some of the stuff that's in OWASP top 10, that's a 700 capacity. And then you have SQL databases, which is only 200. If you have WordPress, you want to use the WordPress ones. If it's PHP, you could do PHP. Ours was a PHP page. I didn't use this particular rule set because the core rule set does block the cross-site scripting, and the SQL one will block the SQL injection. There's reputation lists and other things you could add, as well as some third-party roles here. And these are capacity 1000. This is a OWASP 10 complete role set. You actually have to pay for these, it looks like. Subscribe in Marketplace. GeoGuard, so IP fraud detection. And then the last one is the Imperva Managed Roles Group. I'll go ahead and cancel that. And now we see there's a rule set in here, cross-site scripting SQLi 2, which is going to be from our Terraform. So we could go ahead and take a look at that, look at rules. All right, so we have two rules in here. the SQLi, and then the common role set. So if we go back to the command line, we see that that has finished to where resources were added, so our two role groups. Now if we go back to Kali Linux and try the cross-site scripting again, we get a 403 forbidden. So this was blocked by the load balancer. And the same thing will happen if we try it with SQL map. I'll go ahead and clear the directory because it caches previous results. So let me just remove the output. So if we try the database dump again, this won't be able to find anything, and we'll get an output similar to the one we did with hacking hidden page 2, which reported that it was not injectable. So if we go back here, okay, so this is working because I did not change the URL, which I'll get to in a second. But so if we go back to burp, we need a new burp file. And this is out of the scope, so it didn't find it. Another thing we could do is just change the burp file manually. So we'll take our load balancer URL, and then we were using burp2.txt. So we'll modify the host. And we'll run that command again now. So it identified AWS WAF, and we'll continue anyway. So it says might be vulnerable still, and then it's also trying a SQL injection. This will not work though because our WAF firewall is going to block it. So and it flagged it as critical, meaning it's probably not going to be able to inject on it. So this will go through all the tests again. One other thing you could do if you're trying to hack a page, so for example, if we take off the parameter, this will still load. If you go to view page source, you get an IP address, which in this case is the IP of the server. Now normally this wouldn't be in the source code. There are ways to actually get the actual IP of the EC2 instance, or a lot of times you'll use a scanner to check for any, say, Apache web servers within the range 54.86, because people know that's AWS IP range used for EC2 instances. So by checking instances in that range, you'll be able to find some web servers. So here we see we have .243, and that matches our EC2 instance in the auto scaling group, which is .243. So let's go back to Kali Linux, and then we go back, we see 403 forbidden. However, if we go to the IP address of the EC2 instance, it's still vulnerable to the SQL injection. So even though we have a load balancer with WAF, the WAF does not protect the EC2 instances themselves. It only blocks requests going through the load balancer. So how would you block someone from accessing your EC2 instance directly? The way to do that is to put it in a private subnet. So your load balancer is going to be for requests coming into the public subnet, and then that's going to be able to route the request to your EC2 instances in a private subnet. So the only way to access those is through a load balancer. You can't get to them directly because the subnet does not have internet access. So let's go ahead and see where it scans at. It's checking Microsoft SQL Server. That's still going. So it's going to time out and give a response similar to this one. So in order to make the EC2 instances private, we have to modify the load balancing and auto scaling Terraform file. So I'll comment the public subnets, enable the private subnets, and then we also need it to relaunch the instances. So I'm going to go up to 2 and then back down to 1. So it will terminate the oldest one. We'll go ahead and apply that. And then after this finishes, I'll show you one more thing you could do with AWS WAF to block some attacks. So if we look at our console, there's going to be a second one launching in a moment here. Okay, so Terraform updated the auto scaling group. And we could verify that in the console. So it hasn't taken effect yet. It still says desired capacity 1. So that's still going. While that's running, we'll check on our SQL map. Okay, now it's trying Oracle. If it was SQL injectable, it would have found it by now. So it should be almost done. We'll check on the Terraform. So it's still modifying the auto scaling group. But now we see that change to 2. And if we look at our instances, so we have 2 instances now. And once this finishes, I'll go ahead and change it back to 1. So this finished. And you can see we have public subnets as well as private subnets, and they each have their own route table. So we'll scale this back down to 1. If we look at Terraform plan, we can see what it's planning on doing. All right, so now it's getting the state of all the things. And from there, it's going to calculate what it needs to change. So one thing to note with the private subnets, you'll need a NAT gateway if you want them to access the internet for updates, so that allow outbound access, but no inbound access would be allowed. I'll give this a few more seconds to load. Okay, so here are the changes. Terraform will perform the following actions. So it's changing desired capacity from 2 to 1. Max size and min size are going down to 1. So the plan is to change one resource, and it will not destroy anything. However, it will destroy the EC2 instance when it tries to scale down. And if it works correctly, it will destroy the oldest one, which will be the one in the public subnet. So, for example, we have this one here. You see it has no public IPv4 address. This is the one we just added. It's initializing. The older one, it didn't replace, and that still has the public address. So that's still accessible through the public internet and subject to cross-site scripting as well as SQLi. So when that one's out of service, the load balancer will only be able to route to this one in a private subnet, which does not have internet access. That one moved to stable state. And you could verify the subnet. So we have the subnet ID ends in CB2 and it's named private subnet, whereas this one is in subnet 3F1 and it's named public subnet. So let's check on the status of Terraform. That's still going. And if we go back to Kali Linux, so it's asking a question here. I'll just hit enter for the default, and it finished, and it was not able to get any of the data. We used the -- dump flag, and it was not able to dump the database tables. So the AWS WAF is blocking SQL injection as well as cross-site scripting. Okay, so Terraform finished. Let's go ahead and check the console. It's going to terminate one of those in a second. So we have our desired capacity is 1. Minimum and max is 1, but instances are 2, so it's going to adjust that. Once it realizes it has an extra one. While it's doing that, I'll show you the final part of this demo, which is another feature of AWS WAF, and that is a rate limit feature. So you saw on the Origin tool that goes through almost 26,000 different parameters. However, one way to keep someone from hacking your site is to limit how many parameters they could send. So for example, AWS WAF has a rate limiting rule, which was commented out in my Terraform file. So I'll go ahead and uncomment that. And this will only allow a limit of 100 requests per IP within a 5-minute period. It would be nice if they made that shorter. 5 minutes is kind of a long time, but that's the settings they have available as of right now. So I have this specifically set for any PHP pages, so ends with PHP. And then I have it set to block. You could also have it set to count if you wanted. So we'll go ahead and save that. Terraform apply, auto approve. And with this rate limit intact, we'll try our tools again, so SQL map as well as Argin, and see what happens. So if we go back to the console and refresh here, still running, so it hasn't updated yet. And for Argin, it's going to need the load balancer URL. Which we could get from the Terraform output or from the console. And once Terraform finishes, you'll see a third rule here with priority 2 for the rate limiting. It'll take another minute to show up. Now, rate limiting only uses a few capacity units, so that'll just bump it up to 904 or so. And I don't have logging enabled. And no data is available yet, but normally this would show how many it allowed and how many it blocked. And it's good to run this in counting mode first before you actually start blocking actual requests. So it's going to use a different color here for each type, and then this will also appear in CloudWatch. So what we could do is just terminate it manually. I like it to work automatically though, so I'll just let it go. So this should be the instance that it terminates. Okay, so it's modifying our ACL for the WAF. And one other thing I wanted to show you with the WAF, how it knows to use this role and this ACL with our load balancer that's under the associated AWS resources. Which you'll see the application load balancer here. And so Terraform finished. Let's check our console for the rules, and we see the new rate limit rule is here, and capacity units were increased to 904. You could even go into the individual rules and take a look at them. So we have, if a request matches the statement, URI path ends with string PHP, then it will block it. Okay, there it goes. It terminated the instance, and it terminated the one in the public subnet. So the one we have left does not have a public IPv4 address. Let's go back to Kali Linux, and we will run Argin again on our page behind the load balancer. So let's copy the load balancer URL. Go to Argin. And let's make sure this page loads in a browser. So we'll copy, paste it in here. And we see the page is loading fine there. We'll go back to Argin. And we'll see what happens. So now this is going to send way more than 100 requests. One thing I noticed, it doesn't block the IP exactly as it hits 100, there's a little bit of delay there, and it may be up to 5 minutes. So we're running it there. So we've already passed 100 requests. And we'll see if it finds any actual parameters. So it did find a parameter because the firewall hasn't updated yet. Normally, if you're pen testing a website or trying to hack a website, you'll be trying multiple pages. So you may be able to get a parameter on one page, but by the time you start checking other pages, the firewall will have blocked you. So let's go back to our AWS WAF. We see the rule is there, so the rule is in place. It's still attached to the load balancer. And we have a new field here for rate limit block requests. And we could change it to 1 hour. It hasn't updated with the data yet though. That will appear shortly. And one way to test if we're blocked yet or not is to just go to the page again. So we're getting a 403 forbidden with no parameters attached. So the firewall is blocking us just based on rate limiting. So when this happens, you can't access the site at all. It completely blocked your IP, and I believe it blocks it for 5 minutes or so, and then you're unblocked, but that stops the automated attack if you're trying to automatically hack the site. And let's go back to Argin and try running it again. Okay, so this time Argin failed, so the firewall is blocking the Argin tool from running anymore. So that is how you block SQLi DDoS attacks, at least somewhat, as well as cross-site scripting using the AWS WAF firewall version 2. I hope you enjoyed this video. Stay tuned for more.